Hello. Okay, so for exponential functions, something that we really have to watch out for is that we have to pay attention to what the base is, because the base is going to determine what our parent function points are. So if you haven't already somewhere, somehow written this down, it all depends on the base. There's an infinite amount of parent function points, pardon me, but it all depends on the base. So here we go. Oh no, I don't want green. Something to know is that your x values will never change, and so that's nice. Your x's will always go from -2 to 2, and your y values will change depending on the what? Yes, the base. Okay, so if I raise 2 to the -2 power, I get 1/4. Okay, negative exponent rule. 2 to the -1 gives us 1/2. If you remember, if you have a negative exponent, that takes the reciprocal of the base only. Anything to the 0 power is what? Oh my. Is 1. Good. And then 2 to the 1st is 2, and 2 squared is 4. Now, what value, if I were to pose this to you, what can this never equal? What can y never be? We know if we raise it to a negative power, it takes the reciprocal of it, but what can y never be? Ah, yes. I can't ever equal 0. You can't, because 2, like we saw in our parent function points, pardon me, 2 to the -1 is 1/2, 2 to the -2 is 1/4, 2 to the -3 is 1/8, 2 to the -4 is 1/16, and so forth. So we're getting exponentially smaller and getting closer and closer and closer to 0, but we'll never get there. So we have, for every exponential function, a horizontal asymptote. Now, if there aren't any vertical shifts, okay, because it's horizontal, so in order for us to affect it, it would have to be a vertical shift, then it's at y equals 0. So for the parent function with a base of 2, it's at y equals 0. So we're going to do the best that we can to plot these points. And our exponential function with a base of 2 is exponential growth, and it looks like that. Now, remember, because we have talked about this, if the base is greater than 1, it is exponential growth regardless of all of the transformations. If the base is between 1 and 0, then it is exponential decay. I'm sorry, my cat just walked in. Go away. Okay, so again, this is regardless of transformations. So looking at this, identify our h and k. Well, it's the parent function, so it's 0, 0. The x-axis is our horizontal asymptote, so we don't have any x-intercepts. We have a y-intercept of 0, 1, and if you think about it, what is anything to the 0 power? Ah, it is 1. So if there aren't any, pardon me, transformations vertically, and depending on the stretches and compressions, then we will always have a y-intercept of 0, 1. Our domain, that is right, is all real numbers or -infinity to positive for interval notation. The range is always going to be based off of your horizontal asymptote for an exponential function. So here we say y is greater than 0 or non-inclusive 0 to infinity. Don't forget, exponential functions can't equal 0. It's impossible. There isn't any exponent we can raise a base to and get 0. So we don't ever cross this horizontal asymptote. I know some rationals we can. This is not one of them. Okay. It is exponential growth, and there aren't any reflections. So we're going to say that we increase from -infinity to positive, not decreasing. Yeah, it is 1 to 1, because for every x, there's one and only one corresponding y value. For every y, there's one and only one corresponding x. Rate of change varies because it's exponentially growing. There isn't an axis of symmetry because it's not symmetrical. We don't have a minimum or a maximum value, and we do have a horizontal asymptote, yay, but no vertical. So, ladies and gentlemen, your exponential parent function with a base of 2. Now, if you look at the next example, okay, up here we can see all the breakdowns. Keep in mind the capital B is the base. That is not a transformation. Some of you should write that down because we are forgetful. It is not a transformation. Little a, little b, little h, and little k are. So if we look at the second example, little a is positive 1, no transformation. Little b is positive 1, no transformation. H is negative 3, so we're going to move 3 units left. K is negative 1, so that means we're going to move 1 unit down. Okay, so setting up our x and y chart, we're just going to have x minus 3 and y minus 1. My view, I know, always, I can't see the parent function points, but I know that the x's go from negative 2 to 2. And I know that my base is 2. So 2 to the negative 2 is 1/4. 2 to the negative first is 1/2. 2 to the 0 is 1, and so forth. Every time your base changes from 2, you're going to have to find new parent function points, just like I did for us right now. Okay, so if we plug in negative 2 for x, we get negative 5. Negative 1, we get negative 4, and so forth. If I plug in 1/4, I'm going to get negative 3/4. If I plug in 1/2, we get negative 1/2. 1, we get 0. 2, we get 1. And 4, we get 3. Now, remember, there's a horizontal asymptote, and it shifts with the vertical shifting. So that means that the k is going to determine, we'll do red, our horizontal asymptote. In this case, it's going to be at negative 1 because that is our k value. This guy. All right. Back to my green, let's graph. 1, 2, 3, 4, 5, negative 3/4. Oh, fudge. I hate when it does that. Sorry, guys. And then negative 4/2, negative 3, 0, negative 2, 1, negative 1, 3. And there it is. So identifying h and k, we've already written it down. So it's negative 3 and negative 1. The x-intercept, oh, so nice. It's in our chart, negative 3, 0. Notice, I paused. Yes, hopes that you would see it. Our HK, is that an actual point on the graph? No, and that's okay. It doesn't have to be. HK at this point is just our horizontal translation and our vertical. Okay, there is a y-intercept, but we don't know what it is, so we have to solve for it. So y is equal to 2 raised to the 0 plus 3 power minus 1. That means we have 2 to the third minus 1, which is 8 minus 1, which is going to be 7. Now, we could graph that. It's not astronomical, but we were just asked to find it. We're good. Domain, all real numbers or negative to positive infinity. The range, again, is built off our horizontal asymptote. So here we're going to say that y is greater than negative 1 or non-inclusive negative 1 to infinity. We will never, ever, ever cross that. Is it increasing? Well, it is exponential growth because our base is greater than 1. It is 2, and there aren't any reflections. So yes, we are increasing. Friendly reminder that the increasing, decreasing intervals are your domain values. The idea is that as your y values increase, x goes from what to what, or as x goes from negative infinity to positive, our y values are decreasing. Okay, we know that it is 1-to-1. We've talked about that. Rate of change varies. No axis of symmetry. No minimum or maximum value, but we have a horizontal asymptote. And in this case, it is y equals negative 1. That is your k value. Write that down if you need to. And no vertical asymptote. Sweet. So there is example 2. But of course, we have yet one more. And what do we see? Some of you, I'm sure, are groaning. We love the b value. Don't groan, embrace it. But we must remember that we have to factor it out. Couple things I'm going to do. I'm going to rewrite this as a negative 1 times 2 so we can see that 2 is the actual base. And I'm going to factor out the 3, which is our b value. Okay, so we can see that a is negative 1. Ah, nice. Now we're going to get to see that reflection. Even though it's exponential growth, because the base is 2, we might, hint, hint, see it as a decreasing function. Our b value is 3, which means we have a horizontal compression, because remember, we put it into our transformation chart using the reciprocal. H is a positive 2, so we go 2 units right. And then K is 4. So we go 4 units up. Let's make our transformation chart. We have B as the reciprocal affecting X plus the H. And then we have A affecting the Y plus or minus the K, in this case plus. Now our base is 2, so remember the x's go from -2 to 2, and depending on the base, we generate the y values. So 2 raised to the -2 power is 1/4, to the -1st is 1/2, to the 0 power is 1, to the first is 2, squared is 4. Okay, do that with all of your different bases. So -2, if we plug that in, we get -2/3 plus 2, so we get 1 and 1/3. -1, we get -1/3 plus 2, so we get 1 and 2/3. If we plug in 0, we get 2. If we plug in 1, we get 2 and 1/3. If we plug in 2, we get 2 and 2/3. For the y's, if we plug in a 4th, we get a -1/4 plus 4. So we get 3, oh gosh, there we go, and 3/4. If we plug in a 1/2, then we get 3 and a 1/2. If we plug in 1, we get 3. If we plug in 2, we get 2. And if we plug in 4, we get 0. Do your best when graphing this, please, to estimate. Now remember, there is that horizontal asymptote, which is affected by the what? Haha, by the K value. So I'm going to go up 1, 2, 3, 4, and I'm going to draw my horizontal asymptote at y equals 4. If we want at this time, we're more than welcome, and by we, I mean you, to write it in the chart. And then we're going to graph to the best of our ability because we've got lots of fractions going on. Okay, so we've got 1 1/3, and then 3 3/4. 1 1/3 and 3 3/4. 1 2/3, 3 1/2, 2 3, 2 1/3 and 2, and then 2 2/3 and 0. So yes, please do your best to get it as accurate as possible. And off we go. Okay, so identify HK. It doesn't mean that HK is on the graph. For us, we know that it's not. You can put it as a point, or you can just say H is 2, K is 4. It doesn't matter. Either one is fine by me. X-intercept, is there one? Yes, and it's in the chart. 2 2/3, comma 0. I know I sound so disappointed. Is there a Y? There is, but this one is not in the chart. So off we go. So I'm going to plug in 0 for x. Y is equal to 2 raised to the 3 times 0 minus 6. Don't forget the negative in front of the 2 because I just did. Plus 4. Okay, so we get -2 raised to the -6 power plus 4. Be careful here. That -6 is only on the base. So when we apply the negative property, it's a -1 over 2 to the 6 plus 4. Okay, and then 2 to the 6. So we've got 2, 4, 8. 2 to the 4th is 16. 2 to the 5th is 32. What is 2 to the 6th? So we 1 over, sorry, 32. Or is it 64? I'm so sorry. That's 2 to the 5th. Duh, Patterson. Plus 4. So then that leaves us with 3 and 63 over 64. I know some of you watching the video are like, hello. Hey, have a little patience, all right? So write it as a coordinate, please. So we get 0 and then 3, 63 64ths. Always write it as a coordinate. Nice job though, you guys. Okay, so domain, yes. If you're noticing a pattern, nice job. It's always going to be all real numbers or negative infinity to positive. The range is restricted, but here we did see that vertical reflection. So we're going to say that y is less than 4. Or we're going to go smallest to largest, negative infinity to 4, non-inclusive. It's not increasing. Is it still exponential growth? Absolutely. But our graph is decreasing. What that means is as x goes from negative infinity to positive infinity, our y values are decreasing. 1 to 1? Heck yeah. Rate of change varies. Bleh. So worrying. Axis of symmetry doesn't exist. Neither does our maximum or minimum. I know some of you like that. I just like character in my graphs. And then horizontal asymptote. Some of you may have already written it in. For those of us that haven't, it is y equals 4. And no vertical asymptote. Wonderful. So there is our third example. Ladies and gentlemen, I hope you enjoyed your exponential parent function.